Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a t cubed plus t square is equals to 36 and we solve this problem for all the values of t. So you see that this is cubic equation or you see here the highest exponent of this equation is 3. So this means that this equation has 3 roots. So we need to find all that 3 roots of the given equation. So here first we need to focus into the right hand side and we have this is t cubed plus t square is equals to this is 36 and we write this 36 as 27 plus 9. We break this 36 in this form. And now further in the next step we have this is t cubed plus t square equals to this is 27 and we write 27 as a 3 cubed plus this is 9, we write it as a 3 square. And further in the next step we move all the terms from right hand side to the left hand side and it will become t cubed plus t square. This is positive 3 cubed becomes negative 3 cubed. This is positive 3 square becomes negative 3 square and this whole equation is equals to 0. And here we need to make the pair of a cubic term and square term as well. So we combine these two terms and it will becomes t cubed minus 3 cubed and plus here we write these two terms are t square minus 3 square and this whole equation is equals to 0. So here further we need a nice cubic and square formula which we can apply in this equation for the values of t. So you know about that if we have x cubed minus y cubed is equals to x minus y times of x square plus xy plus y square. And similarly we need the other formula that is x square minus y square equals to x minus y times of x plus y. So in the first term we use here the cubic formula and in the second term we use here the square formula. So first we apply the cubic formula on the first factor and it will be written as so when you use this formula here it will becomes this is t cubed minus 3 cubed, we write it as t minus 3 times of t square plus t into 3 plus 3 square. Okay, and plus here we use this formula and it will be written as t minus 3 times of t plus 3 and this whole equation is equals to 0. And further in the next step you see here both of these two terms involve the factor t minus 3, so that we will be take common t minus 3 from here and we get the remaining values are from here we get t square plus 3t plus this 3 square becomes 9, and when we take common this t minus 3 and here we get the remaining values are t plus 3 and this whole equation is equals to 0. And now further in the next step we have this is t minus 3 times of this is t square plus 3t plus t becomes here 4t and plus 9 plus 3 becomes here 12 and this whole equation is equals to 0. And now in the next step we need to divide this equation into the two cases. The first case is we write t minus 3 equals to 0 and the second case is we write t square plus 4t plus 12 is equals to 0. From here we get the values of t is equals to plus 3. So this is the first real root of the given equation. And now here in order to find the other roots we need to solve this quadratic equation. You know that there are three methods to solve the quadratic equation. The first one is factorization method, second one is completing square method, and third one is by applying the quadratic formula. So here we use the quadratic formula to solve this quadratic equation, and for this we need to write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 4, and c equals to 12. And we state the quadratic formula as t equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is the our quadratic formula, and here we need to substitute all the values of a, b and c in this formula and we obtain When we put the value of b is 4, it will becomes here minus 4 plus minus square root of b square. So b is 4 square minus 4 times of a is 1 and c is 12, and it is divided by 2 times of a, and here our a is equals to 1. Further, in the next step, we have this is minus 4 plus minus square root of 4 square, and 4 square becomes 16 minus this is 4 times of 12 becomes 48, and it is divided by 2 times of 1 is equals to 2. So from here we have minus 4 plus minus square root of 16 minus 48 becomes minus 32, and it is divided by 2. So here we need to rewrite this equation as this is minus 4 plus minus. Here we know that when negative sign appears inside the square root, it will becomes iota, and we break this 32 as 16 times 2. We know that 16 multiplied by 2 becomes 32, and this square root of minus sign becomes iota, and it is divided by 2. And now in the next step we have t is equals to minus 4 plus minus. We know that the square root of 16 becomes 4 times of square root of 2 into iota, and further we break this fraction and we apply 2 separately on both of these two values in this way. And now in the final step we have t is equals to we cancel the term, 2 times 2 becomes 4, and we get minus 2 plus minus this is also 2 times 2 becomes 4, and we get 2 times of square root of 2 into iota. So these are the other two complex roots of the given equation, and we have t equals to plus 3 be the one real root of the given equation. So these are the three roots of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.